Good morning, good afternoon, and welcome to another VMware webinar, Revolutionizing Healthcare with Modern Data Solutions. I'd like to welcome in two excellent speakers, two handsome gentlemen. We have Carlos and Ivan here, you can see on the right side of your screen. But before I hand it off to them to do introductions, just want to go over some housekeeping items. We'd love to keep this as interactive as possible, so you'll notice an Ask the Questions tab right below the presentation screen. Use that tab to ask us anything, and we'll answer them throughout today's presentation. In addition, we know that you guys are here to hear from us, but we'd love to hear from you. So leave us feedback using the Rate This tab also below the presentation screen. Let us know how we did, how we're doing, or what you'd like to hear at future events. All right, without further ado, let's hand this off to today's speakers.
Hey everybody, I'm Ivan Novik. I'm a product manager at VMware working in the data field.
Hey, and hello everyone. My name is Carlos Boyd and I'm a senior technical marketing architect, also working in data, specifically our VMware Data Solutions, which we'll be discussing here today. So real quick, some housekeeping on our end. For those that are familiar with VMware presentations, or if you've seen a similar type slide, essentially what this slide is saying is that we will do our best effort to keep the conversation relevant to features and functions that are known to be in the product or in future instantiations of the product, but the conversation could get a little creative. And if so, we're just saying that this doesn't necessarily mean that those features or functions will end up in the final product. So with that being said, let's go ahead and start talking about how you can revolutionize healthcare with modern data solutions, and more specifically, how to revolutionize healthcare with artificial intelligence and machine learning. Now, every aspect of healthcare has changed over the past decade, and that change has been accelerated since the COVID epidemic. And not too long ago, hospitals and other medical facilities routinely used flip charts and whiteboards and notepads to record and exchange patient data. And that data will ultimately end up in an EHR solution or any number of purpose-built databases. And over the years, the new applications were introduced that required their own data sets and were loosely connected, if connected at all, to those existing systems and those existing data sets. And it's during the same time that advancements in healthcare technology enabled the use of tablets, digital displays, smartwatches, and other internet-enabled devices, which provide real-time analysis and alerting to medical workers and patients. However, these new systems and devices are at best loosely integrated with older systems, and medical facilities are struggling to provide and maintain the new systems while bearing the burden of this disparate and antiquated systems. In the past 10 years, the number of systems and applications alone have more than doubled, and the amount of data has grown exponentially. And those once modern systems have gradually become outdated and siloed, hindering the ability to deliver the level of care that is required by patients and the comprehensive insight that's desired by medical professionals. In enduring the challenges from dealing with these siloed systems, medical leaders, like many of you, have recognized the urgent need for modernization. And as many of you are in the planning phases or preparing to embark on this transformative journey, while you may call it something different, ultimately you're seeking to remove those silos, provide tighter integration, and eventually provide a fast, flexible, and efficient healthcare service that we're calling here real-time connected healthcare. But there are significant challenges to realizing this vision. There's all those old legacy systems that we just mentioned earlier, in addition to a mountain of technical debt that's been accumulated over the years, and it needs to be interoperable and scalable. not to mention security attacks on healthcare arising, and openly sharing patient data is a huge risk for any healthcare organization. And based on the discussions that we've had with a number of healthcare leaders, medical and IT staffs are struggling to manage the growing complexity of operations, in addition to bridging the legacy and the next generation systems and technologies. Yet, the complexity of healthcare is steadily increasing. New applications and systems continue to be built, and where regulations allow, these systems are operated in the public cloud sometimes, and in those public clouds, they typically require their own data backing services, which further adds to the proliferation of data and disparate data sources. However, there are some positives that are coming out of all this new technology, new development, new devices. This additional data gives us the opportunity for things like using artificial intelligence to drive efficiencies and to realize new types of ways to use the data in the healthcare environment. And what we're saying here is that we see three target outcomes for AI in healthcare. Now, there's really dozens of outcomes or benefits, but we're focusing on three. And those three are the enhancement of decision making, increased operational efficiency, and improve patient engagement. So in the next coming slides, we're going to briefly dive into these three primary outcomes from using AI in healthcare. Whether it's in radiology or pathology or some other health-related discipline, AI can be used to enhance decision-making and personalization in many ways. For example, if you consider radiology, Ivan and I had a conversation with a radiologist, and she informed us that, on any particular patient, there might be 900, 1,000, several thousand scans for a single part of the body. When you think about that 1,000 scans, multiply by tens or hundreds of patients, and having to go through each and every one of those scans individually, it could be a bit monotonous, and at some point could lend itself to misdiagnosis or is very slow to get to a final prognosis from the readings of the various images. Likewise, in pathology, there's thousands of histology slides, and with AI, it allows the reading of those images, be it histology slides or those radiology scans, so they can do it in a matter of minutes, as opposed to taking hours and more probably days to read thousands and thousands of images, getting us to that end result, providing us with answers much quicker, which gives us the ability to do some early determination, also to provide some early intervention and specific targeted therapies for differences or similarities that are found based off of the reading of those various images. The second target outcome in AI in healthcare is increase in efficiency and resource optimization. And when you consider the details that were heavily reported during the height of the pandemic, there was often a shortage of masks and other medical supplies, and medical facilities were struggling to provide optimal staffing. It was overcrowding in hospitals, so on and so forth. And administrative functions like scheduling appointments were shown to be inefficient and error prone. And through the use of AI in these and other aspects of administration and operations, we can greatly increase the speed and accuracy and predict the required levels of staffing or the required levels of medical supplies. And the third target outcome of AI in healthcare is the empowering or improving the patient engagement. And what this entails is with the new wearables and the immediate real-time capability of providing feedback or information to the patient, it allows us to be better informed, not only as medical providers, but also as patients. And from a patient standpoint, it allows them to take a more proactive stance or management of their own personal health, if you will. I liken it to, for those that wear the Apple Watch. The Apple Watch is really good about, hey, you need to stand up. Hey, you need to move around. You're walking differently. Your stride isn't quite correct. These are some of the things that artificial intelligence and then much more sophisticated use cases are capable with artificial intelligence and its ability to provide that improved patient engagement. And in addition to providing tools and other services that can handle routine tasks so that medical staff and administrative staff aren't burdened with routine tasks like handling, the low-level inquiries or doing things like scheduling for appointments, so on and so forth. It gives us the ability to create these AI chatbots that are able to handle some of that lower-level type of interaction with the patient, freeing up the medical professional to work on the more prioritized types of tasks, if you will. And it also provides that information to the patient in a much quicker and much timely manner so that, I don't know if you're like me, there's been times where I've called the doctor and I wait for a call back and they'll get back to me eventually, but it could be, 24 hours later, whereas using these AI chatbots and other tools that are capable or possible with AI, it allows us to get immediate feedback and immediate information from our medical systems. Now, realizing the vision of real-time connected healthcare or providing AI capabilities in healthcare requires more than simply modernizing your infrastructure or building modern applications to replace those old, antiquated systems. It requires modernizing and transforming the data that is used by not only the older applications, but required for the modern applications. And it requires a modern data platform, which VMware has in the form of VMware Data Solutions. Now, VMware Data Solutions consists of several key assets. If you look at the top row here, it shows VMware Tanzu and vSphere, where vSphere provides that modern compute infrastructure platform that's used to host in the modern application platform. Together, they provide advanced features like fault tolerance. You see those features on the right side: fault tolerance, high availability, and multi-cloud scalability. But the two features that I want to specifically call out are software defined, which provides that standardization, simplification, and flexibility, allowing infrastructure and application services to be scaled up or down to meet the desired need or the required need. And it also provides, or is GPU ready. And what we mean by that, and the reason that's important, is that when you consider artificial intelligence, GPUs play a crucial role in that they have thousands of cores, whereas CPUs only have dozens of cores. GPUs have thousands of cores, which allow us to do this parallel execution, which is crucial to speeding up the processing of millions and millions of calculations that occur in training machine learning models. Today, GPUs are very expensive and they are really hard to acquire for a number of reasons. But VMware vSphere enables a much higher efficient use of GPUs as it allows multiple systems or virtual machines to access and utilize that single set of GPUs. But as I stated a few minutes ago, the key to modernization is modernizing the data. And when you look at the middle and the bottom rows, these represent the core components of VMware Data Solutions that provide that modern data platform. So components like RabbitMQ at the bottom left, which provides that high throughput, reliable messaging infrastructure between systems and applications, effectively preventing silos between disparate data sets, if you will. And then if you look at the middle left, you've got Gemfire for those new applications that require a NoSQL database that operates at memory speeds. Or perhaps if you look in the far right of that column, Greenplum. Greenplum is that massively parallel processing analytics platform that provides extreme performance while dealing with petabyte scale and larger data sets. And not only is Greenplum massively scalable, excuse me, I went too far, but it's also highly extensible. Greenplum enables us to operate against structured, unstructured, and semi-structured data, while also integrating and ingesting data from just about any data source, and then reading from, writing to, or exchanging data between various data platforms, be it Hadoop, S3, or any other object-based store, perhaps any other number of relational databases. So it allows the use of preferred data science tools, business intelligence reporting tools, and other machine learning models. It essentially puts Greenplum as that ideal foundation, that central point for modern analytics and for providing that artificial intelligence platform. So when you're thinking about modernizing your infrastructure, your applications, and your data, what does that look like? So this is an example of what I would say is a modern data architecture. It says that there, VMware Data Services, an example of modern data architecture. And at the top left, you see these Internet of Things. So we got all those wearables, those diagnostic machines, sensors, and other internet connected devices. And then below that, we have our real-time users. And at the bottom left, we've got our external systems, all those disparate systems that collectively provide input or source data that we want to utilize. And if you look in the middle, that orange with the orangish colored box and the orange icons where RabbitMQ is, RabbitMQ is the component of VMware Data Services that allows you to send it. You can stream those various data elements to it, and then it can then stream those data or allow various data services or other processors or other devices or what have you to then grab that data from RabbitMQ and either utilize it in real time, or perhaps you need to store that data. If you need to store it in in that fast NoSQL-like manner, you might store it in Gemfire, which is the top box in that VMware Data Services box towards the right, or you might need to store it and analyze it and transform it and provide it for other tooling. In the case of using Greenplum, as I mentioned a slide earlier, Greenplum gives you that ability to store that unstructured, structured, and semi-structured data, and then integrate with all various types of tooling and data science tools for further manipulation and use after the fact of storing the data. Excuse me. Now, I'm going to skip ahead 2 slides to first talk about a really interesting project that we worked on in the past. And it entailed using AI and data to find chemical compounds that could inhibit HIV replication. Now, the details here are extremely technical, but to summarize it, the idea is to look for, you've got this molecule or a database of molecules, and the idea is to look for molecules, known molecules that are able to inhibit HIV, and using AI to be able to predict other molecules that can also inhibit HIV. So in the case of a molecule, or using a molecule example, the idea would be a molecule in itself. What we have to do is take that and to transform this into something that we can compare against. And what's done is that molecule is stored as an embedding. So we take that molecule and we represent it as numbers, or we turn it into a math problem. And the idea is those numbers have any various numbers of dimensions or what have you. But the idea being, as we store those molecules as numbers, it allows us to then do searching against those numbers to find things that are closely related based off the dimensionality and the vector closeness, if you will. We can also store those molecules as graph embeddings, but again, giving us the ability to look for similar type representations and search for similar type representations to potentially, in the HIV example used, to be able to potentially find HIV or compounds that are able to inhibit HIV. So now that we've talked about the precursor to using AI in healthcare, I'm going to turn it over to Ivan to talk about the rest.
All right. Thanks, Carlos. So we're going to continue to drill into the architecture, the data architecture, and how we go about building this modern data architecture at a customer site, at a user site, to build these solutions that we talked about in the beginning, these advanced solutions, these AI-driven solutions, right? So we're going to double click into the VMware Data Solutions software and how we can apply it in these different aspects to build solutions like we talked about in the beginning, the exciting solutions. So I'll start with data ingestion. So data is living in all these different locations. It may be living in Hadoop. It may be living in S3 and object stores. It may be living in other relational databases like Oracle, SQL, Postgres. And so what we do is we start with the PXF platform from VMware, and we use this as a federated query engine to kind of use SQL language to absorb data from the disparate sources. So in order to really operate on data, the first step is we need to start bringing it together, and bringing it together because we're going to combine the data, we're going to join the data, and we're going to use it to enrich itself in order to build these robust solutions, right? Having it out in the disparate sources is not going to help us to create comprehensive analysis. So we use the PXF aspect from VMware to do that. We also use the Apache Spark connectivity. So Apache Spark is an in-memory streaming and compute platform that can be used for both data wrangling, data ingestion, and also for machine learning. And we connect this externally and then can use it to ingest data and pre-process data, absorb it into the Greenplum platform, where we're going to be doing more consolidation and integration with other data. Now, when we talk about data, you certainly have data that are numbers. They could be integer numbers, floating point numbers. These are the most, and you could have like characters and words. But as you start building up data structures, you have more complex data. You have JSON documents, XML documents. You have text data, which could be like in the form of a PDF or a Microsoft Word file. You could have image data from security footage or from medical imaging, video data, and then even from other use cases, you might have network traffic data or log data. and location, geography, and graphical data. So there's all different kinds of data, and we need to map these to data types, which we can embed into our platform and be ready to process this data in a known format that we can work with. So all these different data types can be handled by VMware and Greenplum. And in fact, we can be extensible. So if you had something like those molecules and the HIV inhibition use case, we can actually create new data types that map to real world objects so that we can then store and process that data inside a highly performant system. One of the interesting data types is actually geography. If you're working in a healthcare setting, let's say, there could be there could be scenarios where you have sensors that are tracking even people's motion, in future scenarios. So geography really brings the real world aspect of data, because things in the real world move around, and without understanding where they are in the real world, that's a key element to processing that aspect of data. So our platform understands geography. It can bring that in, and it can reason on geography. It can also understand and map graphical relationships. So if you think of a social network, if you think of in the context of genes, in the context of supply chain or chemistry, there can be these, or epidemiology, think of patient zero and passing a virus to the next person. That creates a graph, right? Who is the connected to who. So all of these aspects of graph data can then be tracked and stored inside our platform that we can use to understand and analyze and prepare the data for usage with the full knowledge and respect for the type of data that it is. Some data might be in the context of a time series. So it could be, for example, a heart rate that you're measuring, or over time, or other kind of signals that you're measuring over time from a sensor, where you're seeing how does those sensors move, and being able to see when they're irregular, or what type of subcomponents there are in this time series. Is it moving subtly up but still with a repeating curve? Right. This analysis is very important to do deep understanding of events in the real world. Text data. So if you have communication, feedback from patients, or medical documents, literature, scientific literature, right? Being able to absorb that data, or say official policy documents, or even legal data, right? That's all in the format of text. So we need to be able to index, store, and process text data. Now, the text data actually is revolutionized in recent days with AI, and we're going to get a little bit more into that today. But at the very basic level, text data needs to be stored and processed within a data platform to have a full comprehensive view of the scenarios you're working with. Going forward to how does text data change now that we have AI? So when we look at unstructured data, and again, structured data is things like rows and columns in an Excel sheet, right? I've got a history of check-in, check-out to when I came into work, right? That's structured data. This employee ID came in at this time, came out at that time, at this location. That's structured data. Unstructured data might be something like a voice transcript of a conversation a patient had with a software system. Right now, the voice data, you can't put it into rows and columns. It's just this long recording of their conversation. So how do we take unstructured data, whether it be voice or text or images or video, and really start to use AI to understand and make meaning of it? And the way that it's being done, especially since 2018 or 2019, with the introduction of some new neural network technologies, and neural networks are software which model the way the human brain works, is that we use these transformers, this AI neural network transformers, to process this data. And the way that works is that the step one is we have to convert unstructured data into vectors. Now, this represents, in a sense, a multidimensional vector space, this image, where there are these different points at different locations. And so if I want to know these 2 points here, this little purple point and this little green point, and are they similar, they're going to be more similar in their context to something somewhere else in the vector space. So we use artificial intelligence to convert voice data or text data into a different language, which are mathematical vectors. And based on those mathematical vectors, we can determine their similarity, and we can reason and process on them and build AI applications. So that's the introduction to how this works. And then what can it enable is essentially, for starters, it can enable semantic search. So semantic means meaning, right? And so historically, you may have heard of, for example, you're doing a Google search and what keywords am I using for my search? Because it's matching those keywords. If I search for Bob the Baker, it's going to find, literally something where it says Bob the Baker based on those keywords. But what semantic search means is, even if the words are completely different words, search for the meaning. And when you start searching for things based on meaning, you don't need to know ahead of time what words might have been used. So if you're looking for scientific papers as part of an application that talked about pneumonia and it talked about antibiotic therapy, well, you may put in something that's subtly different. But what this can do is that it can find documents that have the same, that are most similar to what you're searching for based on meaning. And it's so crazily advanced, you don't even need to search in the same language. So you could be searching in English, but the actual document was, let's say, originally written in, let's say, Portuguese, right? And because the vectors are created for each document and for each search term, they can still find which one is similar based on matching the vectors, even though you're searching in a different language. Or if you're searching in words, you could be finding things that match the image that correlates to that, or to a video. So this AI use case, which is literally deployable and usable today, is new and is groundbreaking. Moving forward, the interesting thing here about the VMware platform for data is that it's not just a single application. The VMware platform consists of this wide breadth of tools and applications and modules. And the reason that's important is because it's not just, for example, the ability to search for a scholarly paper that matches what you're looking for. You need to build entire solutions. So you need to be able to incorporate other aspects of data, whether it be time-based filtering, graph-based filtering, keyword-based, geography-based, or altogether different types of processing that can be combined together. And this is an example of how we can do this highly efficiently, is that we distribute the workload out to this huge grids of computation. And that could be using the VMware infrastructure, and then also connected to CPUs and GPUs. And we can apply state-of-the-art AI models to do things like classification of text, summarization of text, translation of text, text generation, as some of the example use cases. We can also apply technologies in the VMware platform that are a bit older, but still super powerful. So although AI may be the right aspect for 30% of your problem, you may also need some other techniques like traditional machine learning based on statistics and do something like a principal component analysis or a k-means clustering. All of these kinds of algorithms can be available and combined in the VMware platform so that you're picking and choosing and building solutions using this wide range of tools. You can also use programming directly on your data. You could be applying Python or Java in this supercomputing kind of grid of hardware. And when I say supercomputing, it doesn't need to be an expensive amount of hardware. You could be deploying this on a very small environment with a few virtual machines to start out. But all of this capability in the VMware data platform can extend to petabytes of scale, or it can start teeny tiny small, or even potentially even on your own laptop to start out. But it could scale to massive enterprise application. So you can use Python, Java, R language to wrangle your data, to get it into the right format, to prepare the data, because even when you're building AI models, as Carlos was saying, organizing and preparing the data, labeling the data is a key aspect to being able to build intelligent models. So you need to have a full platform where you can store, modify, manipulate data, and train and use it in production in highly scalable ways. One of the hot topics, as Carlos mentioned, is the hardware. So CPUs, by their nature, are general purpose. So CPUs are used is the primary computer engine for all software that's running today, or large numbers of the software that's running today. It just so happens that the GPU is really, really optimized for artificial intelligence. And it actually is so optimized that it's highly preferred and recommended to use GPUs for AI. And so we recommend that VMware combining CPUs and GPUs into data platforms and doing it efficiently using the software-defined data centers, so that you can share this hardware, you can repurpose the hardware, you can slice and dice the hardware to make it economically efficient in terms of deployment, and having this kind of from infrastructure up to data processing, having a smart solution. There's a lot of advancements there. We're going to keep an eye on it, but VMware is continuing to certify new hardware. So if new hardware comes out, we're always working to certify the next thing. Even if there's a new dedicated AI acceleration technology, we're going to keep updating the infrastructure VMware provides to make those software defined and available in our customer environments. So really, it's about this whole ecosystem. It's not about one magic tool, right? It's having a set of tools and a set of infrastructure for data that you can use to store, process, categorize, organize, train, learn, deploy, and all the pieces you need with composable infrastructure to build an ecosystem that you can continue to enhance, right? And having that capability as an organization. So it might seem a bit overwhelming if you're sitting there with, lots of existing systems that are ready or having their own issues, a lot of existing demands on your time and on your people's time. So how do we bring this all together tactically and strategically? And how does VMware help the healthcare industry and help customers to take the next step? And really, we recommend both a combination of thinking tactically and thinking strategically, right? So VMware think of VMware as your partner in the data journey, and can help you to have the infrastructure, software, technology, strategy, and people to help you on this journey towards your success. And really, you want to start with some tactical, what we call quick wins, identifying within your business what are the current pain points that everybody agrees need to get resolved. What are the current hot issues, priority issues that if you're working on that problem, nobody would complain or think it's strange. You're solving the most important thing in your business that's right in front of you now, and doing that with data, right? Identifying those quick opportunities, and not worrying if it's the most advanced or future looking architecture or solution. Identifying how to solve those quickly. At the same time as you're doing quick wins, think strategically about AI and data. And that means building infrastructure, both human infrastructure in a sense and technology infrastructure. Human infrastructure, I mean, is your team, investing in your team to learn new skills, because you won't be able to hire a whole team of AI experts, because AI is changing on a continual basis. Even the people who are so-called experts are learning new things all the time because the technology is changing all the time. So what's more important is to invest in the people you have. If you want to have smart people, good people, hardworking people, and continue to train them to learn these new technologies, these new platforms, and at the same time building infrastructure, building starting at the virtual machine and the container layer, but then at the data layer, building infrastructure that's reusable and composable, that can be building solutions in the long term that can store, manage, process, and make available data for lots of different use cases, right? So, and then staying agile, and what that means is being able to change direction. So being able to continue to speak with your stakeholders and your your users and making new priorities and changes that you can deliver new quick wins. But over time, these new quick wins will start using your long-term strategies, start using your AI and data platforms that you're building for the long run to start delivering quick wins in more sustainable ways. So really, you've got to focus on quick wins and long-term improvement of the organization while maintaining agility, and lean on VMware. We have all these different software, we have all these different technologies and all this experience working with customers on their data and AI journey. So lean on VMware, engage VMware, and then we'll help guide you and focus, first on quick wins, but also long-term AI and data strategies so that you really can take advantage of all this potential that's coming in the future. So I don't know if we can bring back Carlos onto the screen here for the wrap up. So thank you very much, everybody, for the joining the presentation. Carlos, you want to say last word? I think still on mute.
Sorry about that. Yeah, thank you everyone for joining. We do have a couple of questions that were submitted. I know we've got a couple of minutes. So do we want to go ahead and answer those real time?
Yeah, where you want to read them out?
Sure. So the first question we have is, can you query data from the file system with Greenplum?
The answer is yes. We can query data from a file system. Greenplum, what we do is we'll use the PXF module, and the PXF module can read CSV files, text files, JSON files, Avro, ORC, whole variety of formats, and you can directly query it from where it sits in either a Hadoop file system or in another kind of file system or in a S3 kind of object store. So that's part of the thing, is how do you bring the data together, whether it be, from all the different locations that it's living in.
Yep. And there were three parts to the question. That was the first part. Okay. Really, sure. Three separate questions, but posed as one. The second part is it possible to work in a schemaless fashion like Apache Drill?
And the answer is yes. So, and we've got to expand the scope here, because the VMware Data Solutions and architecture, there's a whole suite of products, starting, with RabbitMQ, Gemfire, Greenplum, Postgres, and there's schema evolution features where you're dynamically adding new columns of data as you go and modifying your schema. Most of these platforms that we have support schema evolution, and there's features and techniques kind of spread throughout the product portfolio to enable schema evolution within your data sets. That's a key. Obviously, you're going to have new types of data all the time, and you need ways to change the categorization of what data you're storing. So yes.
Awesome. And then the last part of that question is, what are the benefits of using Greenplum in a VMware ecosystem over the previously mentioned offerings?
So in the Greenplum in the VMware ecosystem is amazing because it allows you to separate the infrastructure into composable units. You can separate compute and storage. The VMware will virtualize the compute and make available storage that can be scaled up and scaled down separately. So you could have, you can be expanding your infrastructure on the VMware side, up and down on the compute, up and down on the storage. VMware provides some additional high availability capability to keep services running all the time. And really the economies of managing large fleets of hardware gets more efficient with virtualization and with containerization than maintaining bare metal infrastructure. So it's really a long-term strategic, cost-effective way. And it's not really new, right? VMware has been around a long time, 25 years, doing IT virtualization and helping companies achieve better cost performance. And it's the same, once you come to data and AI, you still have hardware and infrastructure you need to manage, right? And the classic VMware stack is going to make that super efficient, but still keep you in control, right? It's still going to be you running it. You, meaning your enterprise, owns that infrastructure or has control over how that infrastructure is purchased and deployed with a lot of flexibility using the VMware platform.
Absolutely. And then the final question is, can users bring their own models for unstructured data processing and classification with Greenplum?
100%. You could actually dynamically import models from Hugging Face. So Hugging Face is a model repository. There's 500,000 models of open source models on Hugging Face. You can also create private repositories that only you have access to on Hugging Face. And from within Greenplum, you can dynamically access all the models from that repository and start using them, both your own models and open source models, and start processing them in bulk scale on your data. And when using VMware infrastructure, you could be attaching GPUs to that infrastructure and using that to accelerate the model execution in kind of in a mass bulk fashion. So you could really process lots of data with lots of models and make it easy to access those models and start consuming them.
Awesome. Awesome. Well, that was all the questions. AJ, you got anything you want to add?
Yeah, well, I just want to give a special thank you to you guys, Carlos, Ivan. Thank you guys for today's presentation. Most of all, thanks to everyone here who's attended, who's watching this live or watching this in the future on demand, for the great questions you guys have supplied to us. There are just a few notes here. If you click on the attachments tab, there should be an attachment to an overview page for VMware Data Solutions, where you can find out more information. There may be a contact us page or link there as well. But Ivan, Carlos, if anyone wanted to reach out to you guys directly, would LinkedIn be the best place?
Yeah, I mean, for us directly, you could always find us on LinkedIn. I think we're open to any connections. Or reach out to your VMware sales representative or customer representative and ask to speak to us through your VMware contact, and they could connect us.
Excellent. And then lastly, I'd be remiss if I didn't mention this, but Spring One at Explore and VMware Explorer is taking place at the end of August in Las Vegas, Nevada, August 21st to the 24th. If you have yet to register for their event or even know about the event, you can click on the link that we provided in the attachments tab. Ivan, Carlos, will you guys be presenting at either one of those events?
Yeah, I'll be at VM Explorer.
Yep, same here. I'll be at VMware Explorer.
Excellent. So if you couldn't get enough of these two gentlemen here online or on your screen, you can see them in person in Las Vegas.
Right.
End of August.
We'll be showing a whole bunch of new stuff in Vegas. So looking forward to presenting that and being able to meet people in person.
Absolutely.
Excellent. Well, again, thank you to you both. Thanks to all of you guys for attending. This event has been recorded and will be available on demand shortly after the end of this presentation. Have a great week. Enjoy your day. Talk to you guys soon. Bye all.
Thanks.
Bye-bye.